Hello everyone, welcome to this video series on cryptography and network security lab. So today we are going to look at program number 9. So as usual, like and share the video and also subscribe to my YouTube channel for notifications on latest videos. So program number 9 is about implementing RC4 algorithm. Okay, so what is the different thing about RC4 when compared to the algorithms which you already done is RC4 is a stream cipher. It is not a block cipher, it is a stream cipher. That is the difference between the other algorithms and this algorithm. So all algorithms like DES, AES, Blowfish and all these things are block ciphers, and RC4 is a stream cipher. So it is going to process the plain text bit by bit or byte by byte. Okay. So some points about RC4 algorithm. So as I told you, RC4 is a stream cipher, and it was designed in 1987 by a person called Ron Rivest. Okay, and it is a very famous algorithm because it is used in protocols like SSL, Secure Socket Layer, TLS, Transport Layer Security, and in wireless protocols like Web Protocol, Wide Equivalent Privacy, and WPA, Wi-Fi Protected Access. So it is popular. Now let's see what is the process of RC4 algorithm for encryption. So first, you will take something called an S array. S means state. So it is just a one-dimensional array which contains some numbers. So actually, the numbers are from 0 to 255. And there is one more array called T array. T array means temporary array. Okay, where the contents of the T array are derived from the key, the secret, the secret key K. Okay, now this is called initialization step. Okay, so filling in the S array and T array, it is called as initialization step. Now after initialization, the next thing is key scheduling algorithm, KSA. Okay, so this algorithm is just going to simply permutate the contents of the state array. Okay, so KSA is going to simply permutate the contents of state array. That is by using the values from both S array and T array. You will see in the algorithm, but it is just a permutation. Then the output of KSA will be going as input to another algorithm called PRGA, pseudo random generation algorithm. So now this is going to use the S array which is already permutated by KSA, and it is going to give out a value uh, which is going to be XORed with plain text. Okay, so the value that is given by the PRGA algorithm is called as the key stream, that is going to be XORed with plain text, that is byte by byte. So it will take a byte from plain text and it is going to XOR it with whatever byte is given by this PRGA, and the output is ciphertext. Okay, it's a very simple algorithm and straightforward algorithm. There is nothing complex about this. So this is the encryption process, and the decryption process is just you take this ciphertext and you put it in the place of plain text. That's all. That is the decryption process. Remaining the entire process is same. Okay. So now I told you that this is called the initialization step, right? So what happens in initialization is this. So you can see the array S, the state array is being filled with the value I, where the value I is from 0 to 255. Okay, so simply the contents of the array S is numbers 0 to 255, 0, 1, 2, 3, so on up to 255. Then what about the temporary array T? So I told you that T array gets its contents from the key K, right? So this is the key given as input by the user. Now the content from K is going to be inserted into or stored into the array T. Okay, so the length of T array is also 256. That is 0 to 255 cells are there in the array, one-dimensional array. Now the key is repeatedly stored in T of I until it gets filled. Okay, so this L is the length of the key. So for example, the key K is let's say pass password, something like that, pass. Okay, now T of I will be filled as P A S S. Okay, the key is over, the key length L is over. Again it will repeat itself, P A S S P A S S. Okay, this process is done until T of I, where I is 255. Okay, until the T array is entirely filled, the key is going to be repeatedly stored in the T. That's all. So this is the initialization step. Now the contents of S and contents of T goes as input to KSA algorithm. I told you KSA will just simply permutate the contents of S, the state array. So they are using two variables here, I and J. Okay, so I goes from 0 to 255 as usual. This is the loop. Now see what is the J value. J, which value is the current value J, which is 0 plus S of 0 and T of 0. We add them together and we mod by 256. Okay, because the size of S and T is 256, we are doing modulo 256. Okay, so once we get this J value, we already have the I value. We are going to swap the contents in S of I and S of J. That's all. This is the algorithm for KSA. It is just simply going to permutate the contents of S. Now the output of KSA, which is the modified S array, goes as input to PRGA algorithm. Again, we use the same variables I and J. Now see here, I value is calculated using this I plus 1 mod 256, and J value is calculated using current value of J plus this value, which is just calculated as of I. Okay, once you get I and J value, we are again swapping the contents of uh, S, S array, that is S of I and S of J. So you can also say that we are again permuting the values of S array. Permutation is being done. Then once the swap is done, you are calculating another variable U, where the value of U is S of I plus S of J mod 256. Okay, so you are getting some value U. Now that the value present at that U, S of U, is stored in K. So this is the key stream. So the value in K is one of the key in the key stream. Okay, so why I'm saying it is a stream, because this line is inside a loop. So this is a while loop, right? So it is going to keep on generating the value K. Okay, and we are returning that K. So this goes as one of the components for XOR operation, where the other component is the byte from plain text. That's all. Okay, so this is how RC4 works. I hope you understood. Thank you.